For generations, mainstream astronomy has taught us that a supermassive black hole rules the heart of the Milky Way. A titan of gravity, controlling the fate of every star in its reach. We've even seen its shadow, captured by a global web of telescopes. But a new discovery has just shattered that reality. The monster we call Sagittarius A asterisk might not be a black hole at all. The heart of our galaxy may actually be a lethal, ultra-dense concentration of dark matter. This ground-shaking research was just unveiled in the monthly notices of the Royal Astronomical Society. In this study, scientists propose a radical new structure, special dark matter, composed entirely of fermions. This fermionic ghost matter aggregates at the galactic center, compressing into an ultra-dense core while stretching outward into a massive, invisible halo. How could something like this fool the entire world? The reason is its terrifying density. It generates gravitational effects so powerful, it perfectly mimics a black hole. And while it lacks a traditional event horizon, the pull it exerts on the stars around it is identical to that of a void. Only a few light hours from the center, there lies a group of ancient stars, the S stars. Wrapped in dust and moving at thousands of kilometers per second, their orbits tell a story. We once believed only a black hole's extreme grip could hold them. But these new findings prove that a high-density dark matter core can also match these extreme orbits perfectly. Previous research has already confirmed that when light hits this lethal dark matter core, the gravitational lensing is so intense, it creates the illusion of a hollow center, a shadow surrounded by a ring of fire. This feature is remarkably consistent with the image from the Event Horizon Telescope. In other words, that iconic photo might not be an event horizon, but a data illusion. More critically, this theory perfectly aligns with the strange deceleration observed by the Gaia probe. Still, the evidence is not yet absolute. We need more precise data to verify the truth, starting with the search for photon rings. Photon rings are the unique fingerprints of a black hole, and in a dark matter core, they shouldn't exist. If we confirm that the heart of our galaxy is not a black hole, then what about the billions of other galaxies out there? This research could completely rewrite the story of how the universe evolved. A century ago, Hubble discovered a startling fact. Almost all galaxies are accelerating away from us. The only exception is our neighbor, Andromeda, heading straight for us at a relentless 100 kilometers per second. This sparked a 50-year mystery. Our local group has massive weight. Our gravity should be pulling everything nearby inward. But in reality, nearby large galaxies are all fleeing outward, as if we didn't even exist. Now, an international team in nature astronomy has found the answer. Using supercomputers, they recreated our neighborhood, mapping the mass, position, and speed of every major player. The arrows you see represent the direction of cosmic travel. The longer the arrow, the faster the speed. The study found that the Milky Way is embedded in a colossal sheet of matter, millions of light years long. This massive, flat structure is forged from both ordinary matter and invisible dark matter. Above and below it are vast, empty voids. This architect perfectly explains the flight of the galaxies. Within this flat plane, the pull of distant dark matter cancels out the gravity of our own local group. Beyond the plane are those hollow voids where almost nothing exists. Naturally, no galaxies would ever come from there. Switching to our own world, Infogrid has mapped 97% of Earth's buildings using an eye. The dataset covers a staggering 2.75 billion structures. Every footprint and every height was recorded with incredible 3D precision. This map is vital for disaster risk and climate modeling, but also for tracking the relentless march of urbanization. It shows a planet in rapid transition. The findings reveal that out of all the buildings on Earth, nearly half are in Asia. That is 1.22 billion buildings in one region alone. Asia also leads in total volume at 1.27 trillion cubic meters, a reflection of the massive urban clusters in China, India, and Southeast Asia. Africa ranks second with 540 million buildings. But there is a catch. Africa's total volume is relatively small, mostly made up of low-rise structures. Interestingly, Finland's per capita volume is 6 times higher than Greece. And at the other end of the spectrum, Niger's building volume per person is just 1/27th of the global average. Turning to the power of nature, between 2010 and 2019, thunderstorms took 30,000 lives and cost $500 billion in damage. A storm can form in under 30 minutes on a hot afternoon, leaving almost zero time for anyone to find safety. They strike suddenly, appearing as if from thin air. But research in Nature just analyzed 2.2 million events across 2 decades. They found that storm initiation is not random. There is a predictable pattern hidden in the soil. It's the hidden dance between soil moisture and wind. If wind directions in the atmosphere align, storms prefer to ignite over moist soil. But if those winds are clashing in opposite directions, the lightning targets the dry ground. And when the soil is wet, the frequency of extreme storms surges by 68%. The true origin of lightning has always been a mystery. But researchers at Penn State just discovered something impossible. Lightning-like discharges don't actually need storm clouds. They can trigger them inside common materials, glass, acrylic, and quartz. And it moves 1,000 times faster than it does in the air, over in just 1/100,000th of a second. The voltage generated is identical to a real thunderstorm. This breakthrough was just published in Physical Review Letters. Right now, studying lightning is a massive, expensive mission. It requires balloons, aircraft, and rockets, tracking hundreds of cubic kilometers of sky. If this desktop theory is confirmed, the cost of understanding nature's most violent spark will plummet, allowing us to finally tame and study lightning on our own terms.